Hey, class, so we're going to talk about some trapezoids today. Sorry I couldn't make it to be with you, but you don't get out of learning. Haha. Here we go. So, trapezoids, this is going to be your assignment. So, your assignment's going to be page 444, questions 8 to 11, 16 to 20 even, and 37 to 44. Alright, so trapezoid, it has only one set of parallel sides. You see that marked by this parallel symbols right here. Those sides that are parallel are called the bases. The sides that are not parallel are called the legs. So this is a leg, this is a leg. Sometimes you might come across an isosceles trapezoid. Isosceles trapezoids, special types of trapezoids where the legs are congruent. You see I marked congruent right there in a tick mark. This leg is congruent to this leg right here. If those are the same, then it's called isosceles trapezoid. There's a couple things that are special about isosceles trapezoids. First of all, what I'm calling the leg angles, that's not a name in your book, but the angles at the end of legs, this one and this, they are supplementary. That's because you got the lines that are parallel. Here's parallel. You got this transversal. It's like we learned earlier in the school year. Well, that's consecutive interior angles. They're supplementary. We use that on parallelograms on the last couple sections as well. Same will be true over here, that this is, and this and these two angles right there at the ends of this leg are supplementary. But a base angle, which is a name that is familiar in your textbook, it's something they're going to say in your textbook, those angles are congruent. This is another base angle. Those are base angles. Those angles are congruent. So base angles are the angles at the ends of the base, and they are congruent. And another thing you might want to be aware of is that the diagonals, these green lines, they are congruent to each other. So, one more thing, let me go back. So that means that when this breaks up, this section is congruent to that section, and this section is congruent to that section. All right, might be useful. All right, so we're going to try these questions for isosceles trapezoids. What is the measure of angle A? What's the measure of angle B? What's the measure of angle C? Knowing this is 70. Well, I said the base angles are congruent, so that's 70. And the angles at the ends of the legs are supplementary, so that would make this 110. Same thing here, 110. Whoops, 110 degrees. It's 110 degrees. You can kind of imagine it like there's a line of symmetry right down the middle, and everything on the left is congruent with everything on the right. Same thing here. A line of symmetry right down the middle, if I could draw it straight. Everything on the left is congruent to everything on the right. So these are congruent to here. This is congruent to that one. Okay, like I said, the base angles are congruent here. Base angles are congruent there. All those things are congruent. Okay, so there's the answer to your question. This is 110. B is 110, and C is 70. All right, you can use that for some questions on your assignment. As I stated earlier, so this is going to be 6 and this is going to be 10. It's kind of like there's a line of symmetry right down the middle, and everything on the left of this trapezoid is equal to everything on the right. So how long is AC? Well, this is 10 and this is 6. That means AC is 16. Okay. All right, there's something else you need to know about trapezoids. Something called a midsegment. The segment connects the midpoints. We're going to assume that this is the midpoint of the legs. There's a midpoint legs. It's the segment that connects the midpoint of the leg. So as you see this thing in the middle, midsegment. To find the length of the midsegment, it's half the sum of the bases. In other words, you might see half B1 plus B2. You can call this one B1 and this one B2, or you could switch it. It doesn't really matter which one's B1 and B2. Okay, but that's how you can find the midsegment. So for example, find the midsegment of this one. Half the sum of the bases, well, one of your bases is 40 and the other base is 60. Half of this sum, which is 100, means the midsegment is 50 centimeters. Okay, half the sum of the bases. Add the top, add the bottom. Divided by 2, you got the midsegment. Well, in this case, you're supposed to find one of the bases. Let's call it x. So the midsegment in this case is 40. I'm changing this with 40. And half the sum of the base is 30 plus x. And there's a couple ways you can solve this, but I imagine most of you are going to do some distributing and take half times 30, half times x, which means it's 15 plus half x, or you could use 0.5x if you really wanted to. Okay, and then you're going to subtract the 15 from both sides. And that would make this, what's it going to be, 25 equals half x. And if that's the case, if half of x is 25, then a whole x is 50. Or in other words, times this by 2, and times that side by 2. 2 halves makes a whole x, and 2 25s makes 50. Your answer is 50. If you want to check and make sure it works out, you remember add the top, add the bottom. That's going to be 80. Cut it in half, you get the mid segment. We're going to do another one. It's the same idea, but this one's got variables in it. Okay, so the mid segment, which is 8x, is equal to half. The sum of the base is 6x plus 10, plus the other base, 12x minus 30. Okay, you still can do this. You just got to combine some like terms. You got 18x's. Combine this positive 10 with negative 30. That makes this negative 20. Okay, so 8x is equal to all that. Half of 18x, when you distribute, is going to be 9x's. And you're going to distribute half of 20, which makes it 10. Okay, so now you got 8x's is equal to 9x minus 10. You're going to subtract that 9x from both sides. Just a little basic algebra here. It's a little bit more complicated because you got to have a negative x, which throws some people off. And don't forget this is a minus 10 or a negative 10. So if negative x equals negative 10, that means positive x equals positive 10. Or if you prefer, you could treat this like a negative 1 and divide negative 1 from both sides. Either way, your answer is going to be 10. Now, I could have said also find a value of, I don't know, call this like AB or something, and find the value of AB, which is 12x minus 30. Whoops, 30. And then you go ahead and put the 10 in place of the x right here. And that'd be 120 minus 30, and you figure out the answer. It's going to be 90. Okay, so that's the basic idea. Sometimes the question might say find a value of x. Sometimes it might say find a length. Okay, just be careful. Make sure you're actually reading the question and answer it. Okay, there's your assignment. Hope that worked out for you. Watch the videos many times as you need. Good luck.